Hi everyone, for today's lesson we are going to learn how to evaluate nth roots and use rational exponents. Before we get started though, I would like you to please factor the following expression. We have 27x cubed plus 125y cubed. Please pause the video, complete this form up on your own, and when you're ready, please restart the video and we will see how well you did. Alright, this problem is called a sum of cubes, which means that whenever we factor it, we break it apart into two parentheses. In the first parentheses, we will have a binomial, and in the second parentheses, we will have a trinomial. In the binomial, we're going to take the cube root of each term. The cube root of 27x cubed, that's equal to 3x, so 3x goes into the first position. For our second term, we're going to take the cube root of it. And I'm going to take the cube root of 125y cubed, and I end up with 5y. The sign between these two terms is a plus, so in the binomial, we will also have a plus. Then we're going to use our binomial to come up with our trinomial, and this is where we use square opposite product square. 3x squared is 9x squared. The opposite of a plus is a minus. 3 times 5, that is 15xy. And 5y squared is plus 25y squared. So hopefully this problem was easy for you. And if it was not easy for you, please make sure that you have a conversation with me as soon as possible. But this is the foundation for what we're going to be talking about today, working with roots other than square roots. So our learning targets for today is for you to be able to say, I can take the nth root to eliminate an exponent when solving an equation, and I can evaluate expressions with fraction exponents with or without a calculator. So some of these you will be simplifying with the calculator. Some of these you will not be allowed to use a calculator at all. So that's going to be a skill that you're going to be practicing in this unit or in this lesson. So the first thing I want to remind you of is what you need to know and study. You need to know and study all of your perfect square and perfect cube numbers and a few more. So your perfect squares that you must know are all of the perfect squares from 1 through 20. So that is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 361, and 400. Those are all of the perfect square numbers 1 through 20. And another one that occurs often is 625, and that one is 25 squared. So you will need to know that one as well. Your perfect cubes that you will need to know are all of the perfect cubes starting from 1 through 10. So that is 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1000. In addition to your perfect cubes, we have perfect to the 4th powers that you will also need to know. You need to know your perfect to the 4th powers, 1 through 5, and that's going to be 2 to the 4th power is equal to 16. 3 to the 4th power is equal to 81. 4 to the 4th power, that's equal to 256. And 5 to the 4th power, that is equal to 625. And then finally, you will need to know your perfect 5th powers, just the numbers 2 and 3. 2 to the 5th power is equal to 32, and 3 to the 5th power is equal to 243. So all of these numbers, I really need you to be familiar with because they are going to occur over and over and over again, not only in this section, but throughout this chapter. And that's because there's other roots besides square roots that we can study. For example, 2 is the cube root of 8. And that's because 2 to the third power equals 8. So we can write that as the cube root of 8 is equal to 2. 2 times itself 3 times equals 8. And so in general, for an integer, let's call it the letter n, that is greater than 1, if you have b to the nth power is equal to a, then b is considered the nth root of a. Like 2 is the cube root of 8, and that's because 2 cubed equals the number 8. So 2 would be that cube root of 8. So an nth root of a is written as the nth root of a. You're going to have a number on the outside of that root, that square root symbol. And that's where n is the index of the radical. So whenever we're looking at square root, notice that there is no 2 there. The 2 is invisible. So there's going to be nothing there. But a cube root has a 3 on the outside, a fourth root has a 4 on the outside, a fifth root has a 5 on the outside, a sixth root has a 6 on the outside, etc., etc., etc. All of the other ones will have numbers on the outside, but a square root will not. So whenever we're solving or looking at real nth roots of a, and we're solving the equation b to the nth power equals a, and we're dealing with something that is either an even root or an odd root, we have actual characteristics that we will need to make sure that we keep straight. So whenever we're solving b to the nth power is equal to a, we're going to let n be an integer, meaning we're going to just simply take, or we're simply going to have something squared or cubed or to the fourth power or fifth power. And we're going to let a be some real number. We have some characteristics about even and odd roots. The first one is if n is an even integer, that means that we're talking about even roots. Let's say that you're taking the even root of a value that is less than 0. That means that you are taking the even root of a negative number. That means you have a negative number under the root. For example, let's say we're talking about the fourth root of negative 16. In this case, instead of saying that we're working with i's or imaginary numbers, we're only working in the realm of real numbers. So that means that we go back to saying no real solution. It would be imaginary. So we go back to saying you cannot take the even root of a negative number because it is not real. We only want to work with real numbers again. So throughout this class, I will make sure that I'm clear when we're working with real numbers and when we're working with imaginary numbers. And for this chapter, we're working with just real numbers. Next we have taking the even root, like the square root or the fourth root of 0 will simply give us one number, and that is 0. And finally, if a is greater than 0, that means that we're talking about a positive number under the root. If we have a positive number under the root, then we will have plus or minus as a part of our answer. So let's say that we're taking the fourth root of 81. The fourth root of 81, that's going to be equal to plus or minus 3. And we're going to use a plus or minus if we are solving an equation. So we're going to use plus or minus if, and I'm going to box the word if, you are solving an equation. Otherwise, we're going to assume that we're just working with positive values and we won't have plus or minus in our answer. But you're going to use plus or minus if you are solving an equation and you have taken the even root of both sides of that equation at some point in time. So that's even roots. Even roots, you can't take the even root of a negative. The even root of the number 0 is just the number 0. And the even root of a positive number could produce 2 solutions if you are solving an equation. Now let's talk about odd roots. If you are working with an odd root, the odd root of a negative number, that answer is going to also be negative. So if I'm taking the cube root of -8, for example, that's going to be equal to simply -2. And that's because -2 to the third power really means -2 times itself 3 times, and that equals the number 8. So it is possible for you to get an answer. If we were to take the even or the odd root of the number 0, like the 5th root of 0, there's only one way to get the number 0, and that is 0. And then if we took the odd root of a positive number, where you have a positive number under the root, like the cube root of 27. The cube root of 27 is simply going to be 3. And that's because 3 to the third power means 3 times itself 3 times, and that is the only way to get the number 27. So there's going to be no plus or minus with odd roots. So if you take the odd root of both sides of an equation, you will not have plus or minus. You're simply going to have an answer. And so one of the cool things about odd roots is that you can take the odd root of any number. And get an answer. So once again, you can take the odd root of any number and you'll have an answer. If you take the odd root of a negative number, you'll have a negative answer. If you take the odd root of a positive number, you'll have a positive answer. And so those are the general characteristics and rules about taking odd roots and even roots. So now in example number 1, we want to find the indicated nth roots of A, where we're going to be working with the equation b to the nth power is equal to A. So we're going to substitute n and a into this equation, and essentially we want to solve for b. So we're going to solve for the letter b. So in letter A, I have b to the 5th power is equal to -32. So in order for me to solve this equation, I need to get rid of the 5th power, so I'm going to take the 5th root of both sides. And when I do that, the 5th power and the 5th root cancel away, leaving me just with the letter b. This is an odd root, and the only number that when multiplied by itself 5 times equals the -32, and that's going to be the number -2. You will only have one answer, and it's simply going to be negative because this is an odd root. For letter b, I'm going to write my equation as b to the 6th power is equal to 1. So I'm going to take the 6th root of both sides. This is an even root. And whenever you have even roots, we're going to have plus or minus in our answer. So that means b is going to equal plus or minus 1. For letter C, I'm going to write b to the 4th power is equal to 81. From here, I'm going to take the 4th root of both sides. This is an even root. So I'm left with b is equal to plus or minus 3. So once again, we have an even root, and we'll have plus or minus in our answer. Let's look at letter D. For letter D, we have b to the 3rd power is equal to -64. This is an odd root. We'll only have one type of solution. So I'm going to take the cube root of both sides, and I end up with b is equal to the only number that when multiplied together 3 times to equal -64 is simply -4. Please be careful when it comes to the number 64. 64 occurs a lot. 64 is 4 to the third power, and 64 is 8 squared. So you need to be very careful in when deciding which we're talking about. Letter E, we have b to the 6th power is equal to 729. Well, we naturally would want to just take the 6th root of both sides, but how are we supposed to figure out what that number is when we don't know our perfect 6th powers? So what you can do is, instead of taking the 6th root of both sides to start, you can start breaking down the number 729 and talk about what you do know about that number and see if you can eventually get something to the 6th power. So what I mean by that is I'm going to simply rewrite b to the 6th, and I know 729 is one of those numbers that I need to memorize, and that is 9 to the 3rd power. So I'm going to rewrite the number 729 as 9 cubed. Well, that's cool, but I still don't have to the 6th power. But what I do know about the number 9 is that the number 9 is 3 squared. So I'm going to rewrite this as b to the 6th is equal to 3 squared, and that number is cubed. So all I did is replace the number 729 with 9 cubed. Then I replaced the number 9 with 3 squared. Watch what happens. We now have a power to a power. 2 times 3 is 6. So I now finally have b to the 6th power equals 3 to the 6th power, and I can take the 6th root of both sides. And this is going to be equal to plus or minus 3. And we're going to have plus or minus because, once again, this is an even root. So we will have plus or minus in our answer. Remember that whenever we're taking the 6th root, the 6th root eliminates the 6th power. Looking at letter F, we have b to the 3rd power is equal to 512. And so if we were to take the cube root of both sides, we'd end up with b is equal to the number 8. This is an odd root, and we will simply have one answer, and that is the number 8. Let's go ahead and flip the page, because now, what if you might not know your perfect 6th powers. You might not know all of the powers that are possible out there. So what we're going to do is we're going to talk about how we can take the 6th root or the 7th root or any root using our calculator. And the way to do that is to work with fraction or rational exponents. So rational exponents is another way of saying fraction exponents. You will probably see a fraction in your exponent position. So because a to the 1/2 power is a number whose square is the number a, or is the letter a, you can write a to the 1/2 power is equal to the square root of a. So the square root of a is really a to the 1/2 power. The same thing is true for a to the 1/3 power. A to the 1/3 power means the cube root of a. A to the 1/4 power equals the 4th root of a. So all of these roots can be rewritten with fraction exponents and vice versa. So in general, if you have a to the 1/nth power, this equals the nth root of a. And that is true for any integer of n, any integer that you're talking about. So you're going to have a number on the bottom that will be either a positive or a negative. A positive number as long as it's greater than 1. Any integer greater than 1. Now, a rational exponent does not have to be in the form of 1/n. It can be in any sort of fractional form. So other rational numbers like 2/3 and 4/5 can also be used as exponents as well. And the way that we would write those is if we had a to the 2/3 power, we would write that as the cube root of a squared. Or a to the 4/5 power, we would write that as the 5th root of a to the 4th power. So essentially, whenever you have something like a to the m/nth power, the bottom number is going to be your root, and your top number, that's going to be your exponent. we would write this as the nth root of a to the nth power. So your bottom number is your root, and your top number is the exponent that will be on the outside. Sometimes the exponent is on the outside of the root, sometimes it's underneath the root. It just depends on the structure of the problem. So in general, for rational exponents, if you were to let a to the 1 over nth power be an nth root of a, and you let m be a positive integer, a to the m over nth power really means a to the 1 over nth power raised to the nth power. It's because all we did here was we factored out the letter m and split it apart into two pieces. A to the 1 over nth power really means the nth root of a, and it's going to be raised to the nth power. The same thing goes as if you have a negative exponent. If you have a negative exponent, remember that negative exponents are not happy where they're at, so you need to bring that whole piece down to make that 1 over a positive m over nth power. And then you can split it apart again, and with the bottom number being your root, this is going to be the nth root of a raised to the nth power. Please make sure that you note that a cannot equal 0 because 1 over 0 is not possible. It's undefined. What's really cool about this is that now you can use your calculator. Before we couldn't use our calculator. Now we can. So I want you to evaluate each expression using a calculator, and I want you to round your answers to the nearest hundredth. So on your test, you're going to have questions just like these. So I'm going to be looking for you to follow directions. If I ask you to round to the nearest hundredths or tenths or thousandths and you round to something else, you'll lose points for not following the directions. So please make sure you are delivering what you are doing. So for this problem, we have 22 to the 1/4 power. And so if we wanted to evaluate 22 to the 1/4 power, we're going to put this into our calculator. And I'm simply going to go 22, and I'm going to use my caret button that's located below clear. Press that button, and I'm going to raise it to the 1 divided by 4 power. You might, depending on your calculator, need to put the exponent into parentheses. So if you have a TI-83, you might have to use parentheses to establish that that number represents the entire exponent so that you can get the answer of 2.17. For letter B, I'm going to put 35 into my calculator, and I'm going to raise it to the 5/6 power. And you'll end up with 19.35. For letter C, this is given to us using roots. So that means that in order for us to use our calculator, we're going to have to change it to fraction exponents. Remember that your number that's your exponent on the outside is your numerator, and your denominator is your root. So this is 11 to the negative 2/5 power. So I'm going to take 11 and raise it to the negative 2/5 power. And I end up with 0.38 as my answer. I'm going to put a little approximately in front of my answers. Approximately 0.38. And letter D, negative 18. Make sure you use parentheses. Negative 18 raised to the 2/3 power. And that's going to equal 6.87. All right. So that's really easy, working with all of the, working with your calculator. But this is Algebra 2 with trig, and we all know that there's a calculator portion and a non-calculator portion. And what you have here in example number 3 will definitely be on your test in the non-calculator portion. So I'm going to be asking you to evaluate all of these expressions without a calculator. And what I'm going to be looking for is for you to be working with prime numbers. So rewrite the bases as prime numbers to help you evaluate. Prime numbers tend to work the best. Sometimes working with non-prime numbers or just going with what you know about those values will actually be very helpful. So looking at letter A, we have 25 to the 2/3 power. Oh, I'm sorry, excuse me, 125 to the 2/3 power. And whenever you see the number 125, what I need to come directly into your brain is that 125 really means 5 cubed. So we're rewriting the base as 5 cubed, and we're going to write that as 5 cubed raised to the 2/3 power. So that's 5 cubed to the 2/3 power. All I did was rewrite the number 125 with something that I know about it. Now I have a power to a power, so this really means 5 to the 6/3 power, and that is going to be equal to 5 squared. And 5 squared, that's going to be equal to 25. So my answer is 25. For letter B, what do I know about the number 8? Well, look at this problem. Before I even do anything, it's being raised to a negative exponent. So this whole piece is not happy where it's at. So I'm going to change this to a positive exponent before I even get started. So this is going to be 1 over 8 to the positive 4/3 power. Okay, whenever I see the number 8, the first thing that comes to my mind is that 8 is 2 to the 3rd power. So I'm going to rewrite this as 1 over, and 8 is 2 cubed, and 2 cubed is going to be raised to the 4/3 power. A trick is that whenever you're distributing, the 3's would cancel away. That's a trick. Or you can say 3 times 4 is 12, and 12 divided by 3 is 4. Just depends on what you see. So this is going to be 1 over 2 to the 4th power, and 2 to the 4th power is 16. So my answer is 1 over 16. Letter C, I have 64 to the negative 1 over 6th power. So I'm going to rewrite that as 1 over 64 to the positive 1/6 power. When it comes to the number 64, you can go with whatever you see. If you see that you're working with 8 squared, maybe that might help. If you want to work with 4 to the 3rd power, that's fine too. It just depends on what you see. So let's say that you wanted to work with the number 8. And you said, okay, I know that 64 is 8 squared. So I'm going to rewrite that as 1 over 8 squared to the 1/6 power. Well, I end up with 1 over 8 to the 2 over 6 is really 1/3. And that doesn't help me, because in all of these problems, I hope that you've noticed so far, your goal for every single one of these problems is to eliminate all fraction exponents. Once you've eliminated all of your fraction exponents, you're done. And unfortunately, the number 8 didn't get the job done. It's not going to work for us. So I do know something about the number 8. I know that the number 8 is really 2 cubed. So I can rewrite this as 1 over 2 cubed to the 1/3 power. And the 3's would cancel away, leaving me with 2 to the 1st, or in other words, 1/2. That's one approach. Or let's say that we start off with 1 over 64 to the 1/6 power. You wanted to work with the number 4. And you saw that this was 4 cubed to the 1/6 power. Okay, 3 over 6 is 1/2. We're still in the same exact position. We still have fraction exponents. And what I know about the number 4 is that this is really 2 squared. So 1 over 2 squared to the 1/2 power. The 2's would eliminate, leaving me with 1 over 2 to the 1st, which is still 1/2. Both approaches will get you the same answer. Just make sure that you're consistent with your approach. And just know that you can always keep going until you get to, you can always approach it from any angle and still end up with the right answer. Let's go ahead and look at letter D. This one's a little bit nicer. We're talking about the number 9, and we all know that 9 is really 3 squared. So this is 3 squared to the 3/2 power. The 2's eliminate, leaving me with 3 cubed, and 3 cubed is 27. There is your answer. Please go ahead and try letter E, letter F, and letter G on your own by pausing the video. And when you have an answer, please restart the video and we'll see how well you did. All right, let's go ahead and look at problem number 16, problem letter E, looking at 16 to the negative 1/4 power. Hopefully you saw that we're working with a 16 to the negative 1/4, and you rewrote that as 1 over 16 to the positive 1/4 power. The number 16, it's helpful to not work with the number 4 and instead work with the number 2. And recognize that that's 2 to the 4th power, because that'll get you your answer more directly and faster. The 4's would eliminate, leaving you with 1 over 2. If you did end up working with the number 4, you would have had 1 over 4 squared to the 1/4 power, which is going to be 1 over 4 to the 1/2 power, which is 1 over 2 squared to the 1/2 power, and you would still end up with 1/2. So regardless of your approach, you can still end up with the right answer. Number 30, letter F, we have the number 36 to the 3/2 power. And what I know about the number 36 is that this is going to be 6 squared. So even though 6 is not a prime number, I can still work with it because it's the one that makes the most sense. So this is really 6 squared to the 3/2 power. And the 2's would eliminate, leaving me with 6 cubed, and 6 cubed is 216. And finally, we have letter G, which is negative 125 to the negative 2/3 power. So I'm going to rewrite this as 1 over negative 125 to the positive 2/3 power. I know that negative 125 is really negative 5 cubed, and I'm going to raise that to the 2/3 power. The 3's would eliminate, leaving me with 1 over negative 5 squared. Notice that I'm keeping the parentheses. The parentheses are important. If you ever have a negative base, always maintain your negative exponents, because your calculator, if you don't have negative exponents, will give you a negative answer, and it's not correct in this case, because negative 5 times negative 5 is actually a positive 25. So your answer is 1 over positive 25. Please be very careful whenever you have a negative base. All right, now we're going to solve equations using those nth roots. And I recommend strongly that whenever you are solving an equation where you have x to the nth power is equal to a and you're taking the nth root of both sides, or raising both sides to the 1 over nth power, it might make more sense to do that, raising both sides to that 1 over nth power, because you can actually use your calculator. Now, some problems it lends itself to working with roots because it's easier. Other problems, those fraction exponents, working with them from the beginning make actually more sense. And I'll explain that in just a moment. In letter A, whenever we're solving equations, and of course we want our answers to be rounded to the nearest hundredths, but whenever we're solving equations, we need to get the variable alone. So I'm going to start off by dividing both sides by 6, and I end up with x cubed is equal to 64. In this problem, we're working with a nice number. So working with roots or the 1/3 power, they both mean the same thing. So you can take the cube root of both sides and say that x is simply equal to 4. Or you can rewrite this as x cubed equals 64 and raise both sides to the 1/3 power. And do what we did up here, where this is going to be x equals 4 cubed to the 1/3 power, and the 3's cancel away, once again leaving you with x equals 4. I do not care what way you approach this problem because we're working with nice numbers. But for B and C, we're not working with nice numbers. In this case, the piece that has the exponent is already isolated. So a lot of us would want to immediately take the fifth root of both sides. But if we were to take the fifth root of 100, it's not going to be productive because we can't necessarily do that. It's not a perfect fifth power. So instead, what makes more sense is to raise both sides to the reciprocal power. The reciprocal of 5 over 1 is 1 over 5. And that's going to leave us with x minus 8 is equal to 100 to the 1/5 power. And 100 to the 1/5 power, that's equal to 2.51. So now I'm going to add 8 to both sides, and I end up with x is equal to 10.51. And that is my answer. For letter C, it's going to be similar. I'm going to start off by getting the piece that is raised to the exponent alone, so the x to the 4th alone, by adding 9 to both sides, and I end up with x to the 4th is equal to 40. Now, I would naturally want to take the 4th root of both sides, which I'm going to be taking an even root of both sides, whether it's using fractions or taking the actual root. But this is an even root, which means I'm going to have a plus or minus in my answer. So one approach is to take the 4th root of both sides, but we now know that we can raise both sides to the 1/4 power. And when you put 40 to the 1/4 power into your calculator, you're going to end up with x equals plus or minus 2.51. And that is your answer. We have one more problem. It deals with volume, and then we are done for today. And it says that the volume of a beach ball can be approximated using our volume model. That volume, and I'm going to write it down here, I kind of lost some space, that volume is equal to 4/3 pi r cubed. So all of this should go up here. 4/3 pi r cubed. And that is where r is the radius of our ball in inches. And we want to estimate the radius of the ball if the volume is 382 cubic inches. We're going to round our answer to the nearest tenth. So I know that volume is equal to 382 cubic inches. So I'm simply going to replace the letter V in my formula with 382. And I'm going to write 382 is equal to 4/3 pi r cubed. Now I need to solve for r. So I'm going to start with the fraction, and then I'm going to work with pi. So I'm going to start off by getting rid of my fraction by multiplying both sides by the reciprocal, which is 3/4. 3/4 times 382, that's equal to 286.5, because I'm rounding everything to the nearest tenth. And this is going to be equal to pi r cubed. Now I'm going to get r cubed alone by dividing both sides by pi. And when I do that, I end up with 91.2. So I have 91.2 is equal to r cubed. At this step, you can take the cube root of both sides, but it doesn't make sense since we're going to be working with a calculator. So instead, we're going to raise both sides to the reciprocal power of 1/3. And when you do that, you end up with r is equal to 4.5 inches. So the radius of this beach ball is 4.5 inches. And that is the end of this lesson. If you have any questions over anything, please make sure that you email me. Otherwise, I hope you have a wonderful day.